Hello friends, in this video I'll be talking about the factors that can affect basicity, and I'll be discussing only one factor, that is pi-acceptors and pi-donors. And previously I have discussed more than one factors about basicity, which can affect the strength of any base in organic compounds. So in this video I'll be talking about the pi-acceptors and pi-donors, how these can affect the basicity and how we can use these terminologies, or you can use these concepts to understand which nitrogen is more basic. Let's have a look at this example. This is amide and this is amine. These are two common organic functional groups. Now, in order to understand why this is less basic, why amides are less basic, and why amines are more basic, because of the presence of resonance structure in amide. Again, this nitrogen lone pair is busy in delocalization, and this lone pair of nitrogen is free. It's not involved in any resonance. Hence, amines are more basic than amides, even though according to inductive effect, this oxygen is electron withdrawing effect, and that should be something else, but resonance effect will dominate, and amides are less basic because of the involvement of the nitrogen lone pairs in resonance with carbonyl group. And amines are more basic because they do not contain any conjugated system, or they do not have any pi-acceptor. So NH2 is a pi-donor and carbonyl group is a pi-acceptor. So in amides we have a pi-donor and pi-acceptor, but in amines we have only pi-donors and we do not have any pi-acceptors. So that was the concept. That's why amines are more basic. The take-home lesson would be the resonance determining the basicity, and amines do not contain any conjugation, are more basic because the lone pair on the nitrogen is freely available. It's not involved in resonance, not involved in delocalization, whereas in amides the nitrogen lone pair is involved in resonance, is busy in delocalization, hence it's less basic. I hope you like this video. See you. Bye.